All right, guys. Are there any questions on any of the homework assignments or any problems that y'all want to see worked? Any problems that y'all want to see worked out?
Could we do one of the ones that like it doesn't matter, like when you have to like the x equals?
You remember from which chapter? X equals.
So like this.
From 5-1? Mm-hmm. So
I don't get how to do that.
18?
17, 18.
I'll look at 18. So we're going to look at problem number 18 from 5.1. Or 17 from 5.1. So we have a triangle here. Okay. Yep. Now this one here, this problem here is based off the exterior angle theorem. The exterior angle theorem states that the exterior angle, which would be this here, 3x plus 6, is equal to the sum of the opposite two interior angles. So the opposite two interior angles, one of them is 24, and the other one is 2x plus 18. So the exterior angle is going to be equal to the sum of the opposite two interior angles. Now we just need to solve for x. So the first thing we do is combine like terms over here, guys, which would be 24 and 18. And if we add those two together, we get 42. Guys, pay attention here. Now the next thing we can is get x. Guys, I do not want to be talking over you. 3x minus 2x would be x plus 6 is equal to 2x minus 2 would cancel, giving us 42. Then we can subtract 6 from both sides, telling us x is equal to 36. Now, I believe the problem asks find the measure of the exterior angle. So x is 36, but the angle itself is 3x plus 6. So 3 times 30 plus 6. We need to plug it back in. 3 times 36 is going to be 108. Plus 6 would give us 114. So that would be the answer. Does that kind of answer your question? Yeah. And most of the rest of them will work the exact same way. We need to find the value of x and then plug it back in. Although some of, I think one of them, 14 or 15, already gives you the two interior angles. Well, if you add those two together, it will give you the measure of the exterior angle. So we don't have to really do anything beyond that. Any other questions?
Can we have like 10 tomorrow?
So when we look at this one here, I want to cover briefly, because what we've done so far, the statements that we have worked, our shortcuts are side, 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 angle, side, angle, side, angle, 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 side, or side, angle, angle. These are the four that works every single time, no matter what it is. If we have 3 sets of congruent sides, it works. If we have 2 sides with a congruent angle in the middle, yep, side, angle, angle, and angle, angle, side are the same thing. And it's the only one that really, when we flip it, it's different. because side, 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 if we flip it, it's still side, side, side. Side, angle, side, if I flip it, it is side, angle, side. Angle, side, angle flipped is still angle, side, angle. So angle, angle, side, and side, angle, angle is the only one really when we flip it, it looks different. But it still works. Now the ones that don't work were angle, 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 or side, side, angle. If we have these setups, it doesn't work. So these are the ones that work. Huh? No. Side angle doesn't work. Now, this one here I do want to talk about briefly, and we call this hypotenuse leg. This is an example of side-side angle, but it only works if it is a right triangle. If we have two right triangles and a hypotenuse and leg, the hypotenuse is the side opposite the 90 degrees. The leg is just one of the sides connected to the right angle. If we have that in two triangles, then they would be congruent. So hypotenuse leg does work, it just has to be a right triangle. And there might be one of those on the homework. There is one of those on the homework. With a hypotenuse and leg. Now the main thing that we're talking about today is Cpctc. Corresponding parts of congruent triangles are congruent. Because for two figures to be congruent, it means that all of their angles and all their sides are going to match up. They're going to be the exact same. Because for two figures to be congruent, they have to be the exact same. So if I can prove that two figures are congruent, well, all of their corresponding parts have to be congruent as well. And that's really what this is, Cpctc. The corresponding parts of congruent triangles are congruent. Because when we use any of these congruency statements, side, 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 angle, side, angle, side, angle, 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 side, or side, angle, angle, are we talking about every single piece of the triangle? No, we're only talking about three pieces of them. But with this, Cpctc, we can go on from being able to say that the triangles are congruent to any of the parts themselves are congruent as well. So look at this here, this first example. Explain how we can illustrate the given information for this hang glider. Well, we're told that angle 1 and angle 2, which are actually in the triangle, they're down here, are congruent. And that these two angles in the middle, RTQ is congruent to RTS. Now it does work out because of our properties of RTQ and RTS are congruent. Now we can also say that angle 3 and angle 4 are congruent because our properties of straight lines and the fact that they are congruent and add together to be 180. Because really here we could say that angle 1 plus angle 3 is 180 because any two angles that make a straight line will add together to be. Well, we'd also say that angle 2 plus angle 4 is 180 because on both of those sides they do make a straight line, so they would add together to be 180, yes? Well, since both of these add together to be 180, we could really say that measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 4, our transitive property of equality. So since they both equal 180, guys, let's don't throw that ever again. Guys, we can set this up here. But what do we know about angle 1 and angle 2? Well, they're equal, they're congruent, yes? So if I subtract them from both sides, because of this amount, we're really left with what angle 3 is. So those two angles will be congruent. So what we do know is that angle 3 is congruent to angle We also know that RTQ is congruent to angle R. Now, what we're really doing at this point here is trying to prove that the two triangles are congruent. Because if we can say that the two triangles are congruent, then we can say their parts are congruent as well. What other piece of information do we have or can I use to be able to say that these two triangles are congruent? Well, what do we have so far? We have two angles, yes? So if we look at all the ways that work, side, or angle, angle, or side angle, angle. Which ones of these deal with having two angles? Well, angle, side angle, or angle, angle, side, yes? Angle, angle, angle is one of the ways that does not work. So what we really need is a side. We need a side length, yes? Is there any side lengths in this figure that are congruent? The middle, RT is congruent to itself, yes? Exactly. So the other piece that we have is the side length, RT, which is going to be congruent to side length, RT. I'm going to erase this here. Now, if we look at both, we do have an angle side and an angle, angle, and a side, yes? Is what that one of the congruency statements or shortcuts that we have. Well, yes, isn't it? So we can say that triangle what? So QRT or QTR or any way that we want to name that first triangle, that's fine. We just need to match it up with the other. Since we start off with Q, we would go SRT. Now, if you started off with QTR, then STR would be the one that matches it. And we know this is true by angle, angle, side, because that's how we knew that those triangles were congruent. Because we have two sets of congruent angles followed by a set of congruent sides. Now, what did it want us to prove? So by this, we can say that QT is congruent to C by Cpctc. Corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. Questions on this here? Explain how you can prove angle A is congruent to angle C. Now we look at this here. So how many sides are shown to us to be congruent? Two, yes? So if I look at the ways that I can prove that two triangles are congruent, given two sides, well, we have side, 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 or side, angle, side. Those are the two ways that work. The other one is the hypotenuse leg, if it's a right triangle. Is either one of these a right triangle? No, we don't have a right angle, so hypotenuse is not going to be it. So we have side, side, or side, angle, side. Well, exactly. Do we know any of the angles? No. So we do have a third side, yes? So we can say that side length AB would be congruent to what? Side length AD would be congruent to? Questions on this here? Because of this, we can say that what? by. Therefore, we can say that angle A is congruent to angle by CPCtc. We do know that this goes, if we look at A and C, A is between the sides that has the 1 and 2 markers. C is between the sides with 1 and 2, so those are corresponding parts. Questions on this here? Because, I mean, we could say the other are true too. The two are congruent. And these, because they all correspond to each other. Questions on this here? We still like this so far? Yes. Let's skip that one and get this one here. Just a little bit of C in the diagram itself just because how the printer ran it off. So I want to look at this one here. Now we'll treat this one here kind of like the homework assignment that you will be doing. You won't have to have it. I'm not going to make y'all write it out like we did the last two. But let's look at this here. Do we have enough information? So if we look at these two triangles, is there enough information to say that these two triangles are congruent? Because what do we have? We have a set of, a second set of, and an angle in the middle, yes? So we can say triangle what? So WV is congruent to? By what? What did we want to prove? What? Cpctc thus angle W is congruent to angle G. W is congruent to G by Cpctc. And that's it. That's an S. Congruent, corresponding part of congruent are congruent. Are and of are not always included in abbreviations. Mm-hmm. Let's look at this one here. That these two triangles are congruent to be able to say that angle F and angle R are congruent. So what would, so we do have a set of guys, and we have a set of sides, yes? What else do we have? Yes.
Oh my god.
Because they are vertical angles. So SAA or AAS. So I can say triangle what? So DEF, D, because since we started D, you went along the line with 1 and then to E. So we started D, go along the line with 1 and then 2. So it'd be DRS by what? Angle, angle, side. Angle, angle, side. Or side, angle, angle. Thus, we can say what? By And that's it. Any questions on any of this here? Or you feel comfortable with this here? All right.
Oh no.
Because, I mean, we could look at this here, explain how to use the measurements in the diagram to find the distance across the pond. Here. Yeah. Because, guys, 68 and 68 are congruent, yes? 55 and 55 are congruent because of vertical angles. So we can say that triangle AED is congruent to triangle CEB by side angle side. Thus, AD is congruent to BC by Cpctc. Hence, BC is equal to 57 by the definition of congruent. Well, what are we talking about? These are segments. Because AB and BC are segments, so it would be definition congruent segments. And that's it.
You show up. Yeah, I know. This kid is expecting it to be solved.
So the homework is on page 255, problems 3 through 8. Now, one of those problems will be, the two triangles will be congruent by hypotenuse leg, HL. If it's a right triangle and the side isn't between them, or the angle isn't between the two sides, there's a chance it would be hypotenuse leg.